Turning is the general term that describes the process of machining parts using lathes and turning centers. The process of turning parts shares many similarities with milling. The primary difference between them is that in milling, the tool spins, whereas in turning, the material spins, as you see here. Most parts that are produced by turning are round, either in their main geometry or will have a significant round feature. The process of spinning the workpiece creates this roundness. As you see here, material is being removed, much like it is with milling. In fact, the action of tool and material is virtually the same. Although there are exceptions, lathes will use round or tubular stock. The spindles and most standard chucks in lathes or turning centers are designed to hold round stock. There are basic manual lathes like the one you see working here, and there are automated CNC lathes and turning centers. Turning centers are the lathe version of machining centers. We'll take a look at them a little later. If you have not already heard of the term screw machine, you will at some point. At one time, these were specialized machines designed for making screws, hence the name. Now the term screw machine refers to lathes and turning centers that are set up to automatically do fast, repeating operations, primarily large quantity of small diameter parts, typically 1 1/4 inch diameter or less. In fact, with the advent of CNC technology in the 1990s, the need for these dedicated machines has declined, since CNC machines can essentially do the same kind of fast and repetitive work that screw machines were designed to do. Here you are seeing a very basic manual lathe. These kinds of lathes are generally referred to as engine lathes or center lathes. They're the most common kind of manual lathe. And as with milling machines, they are made in many different sizes. This is a relatively small but common size lathe and can handle material up to about 6 inches in diameter. But there are lathes that can handle stock that is several feet in diameter. These very large lathes are specialized machines, and very few of our customers use them. You are watching one of the most common turning operations, taking a piece of rod stock and turning it down to a smaller size, which will become the OD of the finished part. One of the reasons rod stock is supplied in a wide variety of precise diameters is to help machinists choose a size that is as close as possible to the size of the finished part, keeping the amount of waste to a minimum, and in cases where the rod stock happens to be the exact size of the finished part, the machinist might not have to remove any or very little material from the OD, saving significant machining time. Again, you can see that turning is not that different from milling. The shape of the part determines what machine is best suited to making the part. It is not unusual for parts to require both milling and turning, and possibly other types of operations in order to machine all of the various features that a part might have. Mills and lathes, or machining centers and turning centers, have broad capability to perform many different operations. In most cases, parts can be finished to completion using one or both of these machines. This is a CNC turning center, a highly automated lathe. It has a cabinet that encloses the work area, it has a tool changer, and as with milling machines, the tool changer is a key feature of the CNC version. This allows for multiple sequential operations to be performed, as you see here, which saves a lot of time compared to a manual operation in which the machinist will have to change tools frequently. As you watch this operation, you will notice that a fair amount of time is being spent in removing material from the center of the rod stock, creating an inside diameter, or ID. A supplier could have saved this machinist a lot of time and money by furnishing this material in a tubular bar shape, eliminating or greatly reducing the need to remove all of this material. While not all materials are available in tubes, or are only available in limited sizes, we should always ask our customers if a tubular stock might make for a more efficient machining process. On the left side of this turning center, you see a lower section. This is a bar feeder. A bar feeder is not a standard part of a turning center, but is an ideal option for a machine shop making high quantities of parts. This allows a machinist to load many pieces of rod stock, which machinists often refer to as bar or round bar, into the loader, which will then feed the rods into the turning center continuously, allowing for the most automated kind of turning. In bar-fed turning, the machine does almost all the work, allowing the operator to do inspection, cleaning, and packaging of parts while the machine is working. And it is quite common for one operator to run more than one such machine at a time. This is a function of how the machining process is set up. CNC technology and equipment make this possible, and this is the most productive and lowest labor cost process a machine shop can achieve. The most advanced type of turning center is one that is equipped with live tooling and has multiple axes. This, simply put, means that the machine will have capabilities of both turning and milling. The main spindle will remain the same, but the headstock that holds the cutting tools will have the ability to turn the tool, just like a mill turns a tool. And the headstock will also be able to hold the tools in different positions or axes. These kinds of machines are, of course, very expensive and are complicated to set up and run. Very few shops will have this kind of turning center, but you can be sure that those that do are doing very specialized machining in large quantities. As with milling, the difference between the manual and CNC versions of turning is the automation. And, as with milling and other kinds of machining, in many cases a manual machine can be just as efficient and productive as a CNC machine. It depends on the shape and quantity of parts involved. Most shops are equipped with both turning and milling equipment, whether manual or CNC or both, while a few shops will specialize in one or the other. Here are a few examples of turned parts. Some were machined manually, some with turning centers. With rare exception, all of the engineering materials we offer are furnished in precision rod stock in many sizes. And most of our suppliers also offer precision centerless ground custom-sized rod stock. This can often save a customer significant machining time in that they will not have to buy an oversized rod and turn the OD down to the finished part size. Let's change gears a bit and take a look at thermoforming of plastics.